Mr. Cannabis.
Vapor pressure deficit measures the amount of room for humidity in the air at the current temperature and is measured in kilopascals, kPa, or pounds per square inch, psi. Air is made up of many gases, including water vapor, and the amount of water vapor in the air is measured as vapor pressure. The current amount in the air is called the actual vapor pressure, or AVP. The maximum amount of water vapor that air can hold, or at which the point it's saturated with water at a certain temperature, is called the saturation vapor pressure, or SVP. So VPD equals SVP minus AVP. This tells you how much more room there is in the air for more water vapor. But don't worry about trying to figure out the values or doing the calculations yourself. You can just look at a VPD chart. I just want you to understand that VPD is the difference between the saturation vapor pressure, or more specifically the SVP of the leaf surface, and the actual vapor pressure of the air. As mentioned before, relative humidity is the most common way to express the air's saturation with water, but it's not the best measurement to predict plant transpiration or water loss. The more accurate way to express the driving force of water loss from a leaf surface is VPD. A high VPD, greater than 1 kilopascal, means that the air can still hold a large amount of water and thus the plants can transpire and dry out. A low VPD indicates that the air is near saturation, and so the plants can't transpire effectively. VPD influences 5 key features in plants: stomata opening, CO2 uptake, transpiration, nutrient intake at roots, and then plant stress. As VPD increases, the plant transpires faster due to the larger differences in the vapor pressure between the leaf and the air. So there's more forces acting on the plant, from the leaves to the roots, and then the plant experiences more stress. As I mentioned in section 1.2, the guard cells protect the plant from losing too much water at a certain point. So as the VPD increases, the guard cells go flaccid and contract, closing the stoma, called passive hydraulic response. But also as VPD increases and transpiration increases, the roots pull in more nutrients with the water, which means that if you're running a high VPD, you can actually feed your plants at a lower EC and they'll get the same amount of nutrients in the end. Of course, I'm not suggesting that you low-level stress your plants continuously in order to save a bit on your nutrients. I'm merely pointing out that as they take up more water, they're also taking up more nutrients, which you should account for when feeding them. So if you only have a few plants without a humidifier, you can feed them at a lower EC than if you had more plants packed together. If you're having issues with VPD, you can always adjust it by changing your temperature, humidity, and light intensities. So increasing temperature by running a heater or reducing your AC usage will increase the VPD, while decreasing temperature by increasing your AC usage will decrease your VPD. So increasing humidity by running a humidifier will decrease your VPD, while decreasing humidity while running a dehumidifier will increase your VPD. Got it? Good. And then increasing light intensity by either moving the lights closer or adding more fixtures directly increases your leaf VPD, or LVPD, in the leaf temps, while decreasing your light intensity by moving the lights further away decreases leaf temps and LVPD. The ideal VPD for average plant growth is around 0.8 to 1.2 kPa. For seedlings and clones, target a higher humidity and a VPD closer to the lower end of the range, say 1.8 or even 1.9 kPa. This is so that you don't stress the limited number of guard cells on your young and fragile plants by pulling too much water from them too quickly. In the vegetative state, you can reduce the humidity to increase the VPD to about 1.0 kPa. This will give you a great rate of transpiration and CO2 exchange for increased photosynthetic activity. And in the flowering stage, you want to avoid excess humidity and keep the VPD closer to the top end of the range at 1.2 or 1.3 kPa. This will not only allow your ladies to build lots of biomass through increased gas exchange, but help mitigate the growth of any molds or fungus on your buds, especially during the late flowering period when the plant isn't as resilient and able to fight off such pathogens. Finally, growers should aim to minimize VPD swings, as frequent VPD swings greater than 0.4 kPa can drop yields by as much as 20%, as the plant functions are less consistent through stomal variation and other processes. Plants always do best with consistent conditions. At night, plants close their stomata and stop photosynthesis. This closure prevents water from escaping through open pores and significantly reduces, if not stops, transpiration completely. To make the most of the night period, growers can take a few steps. First, they should use the nighttime period to keep relative humidity on the lower end to prevent molds such as bud rot or powdery mildew from taking hold. Secondly, growers should aim to keep nighttime VPD close to the daytime VPD range. Plants still need to release CO2 created by respiration through the stomata, so keeping the VPD relatively close to the daytime range is important.